So as George pointed out, my name's Paul. And this weekend was my 28th hackathon in 2 years, which may make you ask the question, what's wrong with you? That's what my wife asks me pretty much every day. But what's neat about it is a lot of the hackathons, you end up with a surplus of hardware and gadgets, and a lot of times you get a chance to play with a lot of things before a lot of people get to see them, and things you don't necessarily have to buy. And from kind of the other angle of it, it's more of a fun event. It's kind of architecture in 24 hours, and it doesn't have to work after you leave the room. So that's what I love about it, or I guess. So I've got a couple slides to talk about my very peripheral vision of what IoT is, and then we're going to dig into some hardware, which is what I thought would be fun to have here at the event. When I saw that this year was an IoT focused event, I thought, why wouldn't we have hardware here? Why wouldn't we have drones? So I did bring one small drone, and time permitting, we might get a chance to play with it. But otherwise, we've got some other cool hardware. There's a couple laptops out there, and there'll be a couple more after we get through the slides. So let's get started. Oops, does it move? There we go. So this is a placemat that somebody in marketing put together. It's, I think, meant to scare people, or it's the picture correspondence to that slide that everybody's shown where the internet is going to be 50 billion devices by 2020. So this is the pictorial version of it. We are really going to drill down here in this corner section here, which is one of the building blocks of IoT, which is the hardware. There's some of these names might look familiar. Arduino, if any of you are kind of garage hackers, Raspberry Pi, Intel, NXP is a kind of new and up and coming, and ARM 18 mega. Just kind of meant to show you some familiar names. So let me just level set. I don't know what level of experience you have, what level of background. So I'm not going to assume that you know anything about IoT hardware or assume that you don't. But just looking at a high level, there's kind of two larger types of hardware. There's the microcontroller, and these are the Arduinos, the Particles, ESPs, and then there's the single board computers, such as the Intel Edison Raspberry Pi. The big difference being, oh, my notes went away. The big difference being the microcontrollers are just single processors, very low memory, quick to process. The single board computers are Linux systems on a chip, more often than not. So take a deeper dive into what microcontrollers. Microcontrollers are a simple computer. Oh, there's my notes. They're often kind of application designed. There's the little round jobber in the corner is a lily pad meant for wearables and fashion. Oftentimes they're custom sized for the application. They're really great for repetitive tasks. They're kind of like the worker bee or worker ant of the world. They just reliably work forever, or for as close to forever. They do simple things. They can tweet. They can drive your robot, but they're not doing any of the heavy level processing. And there's a host of development environments, everything from the Arduino library to being able to program in JavaScript, Python, Lua, and there's even a couple .NET versions of them as well. And then the larger class, the single board computers, these are really just computers on a chip or small computers. The kind of two big names are the Intel Edison and the Raspberry Pi. And these really are kind of what, in some of the other presentations you might have seen, kind of on the edge. They're, in my 28 hackathons, I tend to put these kind of as gateways or do more of the heavy lifting or the security aspect of my applications. But really there's a lot of other different applications for it. More often than not, they have a little bit of memory. They can do a little bit of intermittent storage, but they're the more computational rich devices. And then there's just sensors. And I might invite you up to come take a look. Like I said, there's in all the junk I've accumulated, there's a sensor for things you can't even imagine. Everything from anything you can feel, touch, smell, taste, there's a sensor for. And these sensors are usually high precision for relatively low money. Some of them tend to be a little bit more expensive. I know probably can't convince the guys from Statoil that their sensors are probably pretty inexpensive. But some of them, if you're the kind of hobbyist or backyard programmer, some of these sensors are costing $1, $2, $3, whereas some of the higher level, like this pH sensor here, can be around $30, $40. Okay, and then just a little bit about connectivity. Some of the protocols, Wi-Fi, Bluetooth. Kind of some of my favorites are MQTT. So we'll drill into that a little bit more when we get into the labs. Okay, and then what's in the box? What do we bring today? So I brought a couple Intel Edisons, some Raspberry Pis. I left my Samsung Arctic back in my room, and some of the smaller microcontrollers. A box full of Arduinos, different sizes, a couple interesting boards. This board called the Linkit One that has a built-in GPS battery and cell. Interesting for deploying out into out in the environment with the solar panel and pretty much run it forever. And then just a host of sensors, everything from light sensors, vibration, temperature, gas, and some of these we're going to get a chance to play with. Okay, so. Like I said, I wasn't going to take a lot of time with the slides because I was hoping you guys were more interested in getting around to playing with some stuff. So I've got a couple workstations. There's a little bit more people than laptops, so and I might need a couple minutes to get the people in the back set up with the laptops that I didn't get pushed out. You may need to partner up or pair program. We'll walk through the labs individually. And so the first guy we're going to look at is a board called the ESP8266. This is literally a $2 web server. This particular chip, the one you guys have at your workstation, is called a Wemos. That clocks in at $4 because it has a power regulator on it. And if some of you have the ones with the blue sensor on the top, that's a temperature and humidity sensor. That's another $2. So for about $8, you can build a pretty robust temperature humidity sensor. So let me see. I don't know if I put my USB drive in my pocket or not, or where. But if you've got a laptop in front of you, if you go to the desktop, the first lab is entitled Simple Web Server. It's probably not the one that was left up. Yeah, let me.
Should I move there?
No, I'll bring one over to you because I'm not sure. I'm not sure this one was working for a minute and then I think it croaked.
I can move over there. That looks like a laptop.
Yeah, you can. Here, I'll bring this one over here. Oh, yes, you can sit there. Let's see. Did it power down? Yep. Yep. Give me just 1 second. I'll get a couple laptops down there. So that's kind of the presentation aspect of it. I don't know if you guys want to record me walking around helping people with laptops. It's entirely up to you. You get paid either way, so.
Check, check, check.
Showing my
Do you mind just throwing this on?
Sure.
Just they want us to record everything and
Okay. No problem. Okay. Uh-oh. The files got corrupted. Um,
That's why apparently too much Wi-Fi here. That means the sound is so good.
are you on the right?
Yeah, what is
So if you go up to Tools and Port Com3.
COM3?
Yeah, this is actually a test to see how your hacker skills.
Oh yeah, these guys found new ways to break stuff.
Okay. You guys got it? Upload it. Did you pick the right pin? I mean, right port? So if you go to Tools, and then go to Port, and
It says it's on COM1 according to this.
yeah, so try 3 or 4. If it doesn't work on 3, try 4. Yes.
Power, password.
Yep, and everything else. Yep.
And I know the battery's pretty low here.
Okay, we'll get you an adapter. No love?
Yeah, missing some include files.
Okay. Okay, web server. Okay, so let's see for 1 second.
Yep.
So
Doesn't find this file.
let's try that. If it doesn't work with on COM3, try to move to COM4. Okay. Hey. Yeah. No. So you uploaded it, and go to the serial model. So go to Tools, in the Arduino. Tools. Serial monitor.
What is that?
This is just the serial out window.
Okay.
I'm just gonna hit the reset button here. Let's see if we can get it connected to the Wi-Fi. Yep.
Just
Yep.
opened up
Okay, great.
Arduino.
Let me just put the files on here. Sorry for the mini computer. I guess it's better than no computer, right?
Yeah.
And if we can get it to work, it'll be even all the better. I had the pleasure of, as I was deploying it out this morning, the flash drive got corrupted. It's like, oh, great. Okay. And let me get you some power. Currently use what? And that's that one. Wrong direction.
3, I'm getting,
Sure.
I didn't verify the file first, yeah.
Yeah. And you tried 4 and 3?
I tried 4, and 4 says it can't even talk to me.
Okay.
On 3, it's giving me this,
Memory upload fail. Let's see what happens. Okay, let me log in over here. Again, I'm sorry, I'm not as prepared as I had hoped to be. You got, and once you get it to compile, if you go up to Tools and do Serial Monitor, you can see what IP it's running on. You might have to change the baud rate on the serial monitor. What's that? So, let's see. No, it all looks right. Restart. The old Control-Alt-Delete.
Or plug the device or get back in.
That's true too, yeah. Okay. That's actually not a bad idea. Well, it's registering. It's a good sign.
So where's the battery for that? Is that
It's powered through USB. You can power it off. It's 3 volts, so you can power it off of a cell. Okay, you guys need the files. You need the files as well. Oh, you know what? I left it in his drive over here. Okay. Let me, this one I know will work faster, so let me just get this one going. And you guys probably want a thing. You have no thing. You have no thing?
Yeah, we need a thing.
You need a thing and a file. Yeah. Okay, let that. Yes. What's that?
I don't have,
The files, okay. 1 second. Oh, are you still booting? Yeah. Oh. Okay. Here's a laptop with a thing. It is an ESP with a temperature humidity sensor, and it may already be running. Did you guys get it to run?
It's running, but it doesn't seem to actually.
Oh, you don't. Yeah, you need a. Hold on. It's not blinking. The onboard light. Yeah, because if you change it, does it switch?
Change what?
Go to the website. Okay. Well, that's so.
Poking around.
So go to Tools and then Serial Monitor.
Serial monitor?
Yep. And
Count 4.
and are you on? Change that to 11.11250. Oh, 11520. Does user. Okay. Let's restart it.
Here, opening the port.
We also tried changing the code.
But we didn't re-upload it yet.
You don't. I'm not sure why that's doing it.
I don't even know what it's supposed to do. What's it supposed to do?
It's supposed to bring up a. You're supposed to get an IP address and bring up a web server. Give me 1 second. Okay.
It's on this side.
Yep. Thank you. Yep. And here is a chip. Yay. Here you go. Plug that in. Okay. You need. Yes. Yep. There you go. Here's a thing. A thing. A thing. And you have a thing. That's good. Okay. Did you guys are in business or in business-ish? And you still need the stuff.
Well, you have people with small hands.
What's the matter? Was it coming up?
Work? Well, it's not dinging anymore. It was dinging. It's dinging again.
Okay. Is this still connected? Can we pop that out?
I didn't copy.
Okay. Copy them over to.
So just this folder.
Yeah, just copy the new folder. Okay. And you wouldn't mind ejecting that? Eject right there. Oh, I think you might have it open in Arduino here.
I think so.
Okay, thank you. Okay. Do you need yes? Okay. So what are you getting? Wrong direction command. Ecom sync fail. Okay. Let me see if I can get a. I was having trouble with this USB cable before. It sounds crazy, but let me.
So I guess we're like missing. Yeah, exactly. Missing spikes.
It worked. Do you need a? So there's a folder called New Folder. Copy that to the main drive. Sorry. Just copy to the desktop. Okay. let's see. Okay, so go to 10, 10, 10, 30.
Yeah, so it just clocks. It worked one time and then just clocked after that.
Nope, wrong way.
Maybe you should change the code.
Good. 10, 10, 10, 30. And are you seeing the client connect over here?
Actually, we saw a new client once, but that was it.
Oh, that's the weakness of the reader. It's like a new one. Oh. Not on the. Yeah.
There we go. Okay, turn the LED on or off. Okay, so this is a slightly different board, so we might have to change the pin. Or, look at this.
Or you go into a different drone.
Different drone. Okay. Thank you for your patience, gentlemen.
We switched to weather server.
Okay.
I don't know, we couldn't get the other one working.
Okay. Weather server is a little more interesting.
We like interesting.
Okay. So, did you?
We just got into it.
Okay. So try to pick the. It should have already remembered the port number. Yeah. Yeah. So just compile it and run it, and then we'll open up the serial monitor, and then you should be able to see the IP address, and it'll start registering the temperature and humidity on that one. Yeah.
So what do I need to do now?
Okay. Simple web server. So you're compiling the sketch. Port. We got the port here. 3. And then when it's all set, we'll compile the sketch. Oops.
So what's happening here?
So what we're doing is we're connecting to the Wi-Fi,
Yeah.
and then we are uploading it to the board. And you'll see over here, it's going to connect to the Wi-Fi here. It's connecting to the Wi-Fi. And there's the IP address. So open up a browser and put that IP address in. Okay. You didn't expect me to run it and debug it, right? Okay. Eric, okay, so we got the wrong board type. So we're gonna go. That one there.
Yeah. That's one that they gave us back at the room. From the thermostat. When you're done here, can you come reprogram my door lock? 'Cause it's not working.
What do we have the wrong port?
The wrong board.
Run.
Did you change it? No, I didn't think so.
I just made a microservice. and it's supposed to work. That's what I heard. Microservice is not supposed to.
You made a mini service.
It's still compiling.
Yeah.
I think Rick changed the password.
Yeah, I did. It's iHeart IoT.
Okay. And when you're,
So I got it on.
yep. So you should be able to turn it on and off. You should be able to see the LED change. So that you made your no. There's a bunch of other labs too. If you want to go to the next one. Okay. Okay. Failed to open COM4. So 4 is not our number.
Says we need more lithium crystals. Damn it, Scotty.
Damn it, Scotty.
Cannot change your lock.
I'm a programmer, not a magician.
It's looking like we're not gonna have time for the drones, huh?
plenty of time for the drone. You will if you throw them. Working? Okay. Okay. That's IoT.
Can I switch the? Do I need to switch?
No, no, no. Just go to the weather server. So go to Tools. You have the right board. Yep.
Serial monitor?
Yep. Yep.
So it said failed to open COM 5, so I changed it to COM 4.
Okay.
See what will happen. It says it's on 4, right? Is this good? That means it's not green.
No, it's got now it's uploading to the board. No, so it's it's like it's dying right into the board.
Did the little light go off on the board? I had to unplug that and plug that in.
Now you get the blue light on.
I think there's something with that connection.
It'll change the humidity. Yep, that means
This connection right here.
you think it's we got a loose one.
Yeah, I had to jiggle it around to get it.
There we go. We got it. Okay. So now go to Tools.
What's it doing now?
So now it's got a web server. Oops, COM 4 busy.
Are these the ones that you said always work reliably?
Yes, these are the ones.
Work busy.
Is it so? I thought it said it was done.
You hear the dinging?
Yeah.
That's because that's not connected.
What do you do? Where did you put it?
Let me say, when you get it back,
That may be one of the giveaways. That one's a giveaway one. Oh yeah.
2.14 billion Fahrenheit. 2.14.
Wow.
2.14 billion? Is that the...
Okay, done uploading. Tools. There we go.
Now we're talking.
Okay, so now it's
Bad USB cord, that's what it was.
yeah. Okay, so now the server's going. So if you go to that IP address, you should be able to see it. You should be able to see the temperature. Yes. Sorry. Okay, so let's go up to Tools. Tools. Let's go to Board. Pick. Scroll down here. Board. Scroll down. Just keep going. See the arrow down there. You're gonna pick the ESP Wemos 1 minute. Yep. Yep, that's the one. Sorry about that. And then Tools. Again, let's make sure we've got the right COM port. Okay, I'm not sure if it's 4 or 5. Let's try 4. And then now you can hit the arrow right there. You can start compiling. Oh no, now it's. Let's see. Pull this guy out. Do you copied it to the hard drive, right? Okay. Yeah, you want to try the other port? Would you guys ever get it to, or are you missing a thing? You've got a thing. You okay? Okay. Oh yes, it's only just right. It's only Wi-Fi and it's just using the power. Okay, sorry for ignoring you. You've learned lots. You've compiled it. You run.
Yeah, I've run this web server. I'm actually going to try to run Wi-Fi.
These guys. No. Okay, so mini port 5. Let's try different board just for yucks. Try that, and you might have to pick a different port. Wasn't blinking? Okay. Okay.
Everything's good for us.
Okay. Oh, great.
Question for you.
Yeah.
We changed the USB port and it's plugged into it and everything works.
Okay, great.
How do we read the value from the sensor?
Sorry. Nothing's working over here.
We don't have anything in the
We stole from that,
Yeah.
but I don't think we have the files.
Okay, let me see if I can get a better laptop so you're not looking through the mini one.
I'm changing my password right now. Yeah, you're gonna have to know it's with the code. I'm changing all my routes. That's right. It's gonna be a 2 instead of a 1.
Having some issues.
Okay. Let me, you got the first demo working?
Yeah.
Okay.
I'm getting an error compiling board web mode D.
Sometimes what happens if it gets stuck, you just want to reset it and then change this guy here. Yeah, that's true.
But the IP address will stay same?
Yep.
Okay.
You can display the temperature and the humidity at the same time, right?
You could.
But it's not showing the temperature.
Okay, so you are on the web. Okay, so you're still on the other one. You need to go load the other project. So you're on weather server.
Yeah.
Okay, let me just bring. I'm going to bring this laptop over there and try to see if you can compile that one. Okay, who is completely stuck? Over there. Okay. Here. Still trouble connecting? Let's try this one. Different computer. I know you're going to find this hard to believe, but these computers are all came from the dump. So sometimes they don't work, sometimes they work well, sometimes they work really well. Someone just threw it away. Sometimes it works, sometimes it doesn't. So let's go back to. We're going to go to simple web server. And let's give that a try. I just want to make sure we plug this in. Did you guys, the $1.50 humidity sensor sometimes doesn't work. Really. So.
Is it temperature and humidity in the same sensor?
Yes. Okay, give that a try and okay. Okay, and you guys, you're able to look on a little bit, but that one's dead. That one's working. It's yours. Okay. if you haven't already figured out, or if you've gotten past the first one and you want to go to the next one, there's a humidity sensor. So if yours has one of the blue ones, the blue sensors, you can do the temperature and humidity. And then one after that is one where it actually pushes it to the cloud. It pushes it to ThingSpeak that MATLAB just acquired. And I'll run through the code up here on, and because it's a good example because it shows you exactly how really things work. You know, spinning up a simple web server is a simple web server.
Just going through your
Yeah.
box here, seeing what's in here.
I have a lot of junk.
This is
A moisture sensor.
moisture sensor. Okay.
So you could
Thought
put
I
this like,
recognized the
yeah,
pattern.
put it flat down on like your basement floor. Yeah, so if you're getting tired or want to walk around, please come up and take a look. There is a plethora of strange looking devices that some of them are labeled and some of them are not. Mike, this is the one that I was talking to you about yesterday that's a depth sensor or yeah. So it's a ultrasonic rangefinder. So it's sensitive up to like about a centimeter, half centimeter. Looks like
So it uses two different perspectives?
it's echolocation.
Okay.
Yeah, and you know, at a bargain at like I think $3.40, and it's.
Web server or
Right. So this chip here is a Wi-Fi chip, but it has enough memory and processing power to actually be a simple web server. This is a temperature and humidity sensor in one.
for some reason I couldn't get that to use.
You couldn't get it to register? Okay, let's see if we can troubleshoot it. Okay, COM4. Are you guys getting error uploading or actually compiling?
Oh, no, we're trying to change the code.
Okay, good. At the same time? Yes. So the interesting thing about that one is it's actually got one wire that measures both the temperature and humidity, and it sends one signal and then waits for, a millisecond for the next signal, and that's why it's doing it in two. You could put it into a buffer and then wait for it, but that's why that example is the very simple. Yeah. Yeah. Error compiling, and it's not even. Yeah, that's the other thing I'll show in a minute, that how you can find sample code for every sensor you can find under the sun.
I feel like these are the eyes of Johnny Fox.
Oh, great. So there's one that pushes it up to the cloud. It's called Simple Web Ser- or Web Ser- Weather Server Weather Station with ThingSpeak, and let me show you up here what it is, because it's actually an interesting example, because it really is more of what you would do in the wild. Oh.
T header, I think.
Okay. Oh, okay. You may be missing. That one's easy to fix.
Just plug this into the green board or
No, not necessarily. Some sensors are, you may be able to, are just straight voltage and you can plug them in. And I'm sorry for this laptop. This is my least favorite laptop on the planet.
Yeah, it's been working.
Okay, oops. It's actually a touch screen. Okay, Arduino. After my floppy or my thumb drive died, I had to put everything out here. Okay. So I might need to kill it and then restart it again. Okay. Yeah. Okay. What are you guys looking for? Power cable for the Lenovo. Okay. Yeah, right here. There you go.
We can handle that. We'll take care of that.
Okay. That is a humidity sensor? Yeah. That one, here, let's grab. That one you need, actually there's a shield. Okay. Is anyone done with the humidity sensor who doesn't want to do humidity anymore? You okay? No, just the one off the top. Hi. Sure.
You can take the one to check.
Okay. Here, I want to show you another cool thing while you guys. This is a relay, and this is enough oomph to turn on and off your dryer. This will run at 220 volts, 15 amps.
Yep.
So the best thing is probably to buddy up.
Yes.
Here's the smartest guy in the room over here. You wanna? He got it to work despite all the challenges.
So you just pulled out one sensor and popped in another.
Popped it in.
So it's designed like a
So this is So
consistent interface for different sensors. You wanna pop in?
yes.
That's awesome.
Okay. Here you go. So the only thing we have to make sure we plug it in is, and thank you guys for your patience. It plugs in like that. Okay, great. Oh, thank you, thank you. Okay. Let's see. Oops. Not the right one?
Not the right one.
Really?
Yeah, it doesn't fit. It's too. That's too small.
Just doesn't need to be persuaded? You tried persuasion? Yeah, okay. For some reason I thought that was the right one. Yeah, that'll take this Toshiba one. No. Not that one. There's one that says Toshiba on it. Maybe it's over here. See who's not plugged in, so it's got to be some. Okay. Okay, and you guys, that one. Okay, yep, and that one's working. Okay, yeah, that's the power supply for that one. Yeah, so if you
We can buddy up when.
when it goes down, or we can swap off. Okay. If you guys want to, for a quick second, I wanted to show you kind of the penultimate example, which is once it launches here, kind of gets to the real kind of heart of the Internet of Things. I mean, it's the simple web server is kind of novel and but this is kind of like the goods. So let's do it this way. Come back. Okay. So again, thank you for your patience kind of going through this. I had a little unfortunate technical things at the beginning. But just to walk through the code, just so you know what you did, because obviously you just looked at it and compiled, hope for the best. But if you wanted to look a little bit more, again, I apologize if you've already been through this. Just like most programming languages, there's a couple libraries you include. The little blue chip on the top is a DHT11. It's the most inexpensive at about $1.50 temperature and humidity sensor. There's a DHT 22, which is significantly more accurate, coming in at about $3. The chips that you have there, that particular form factor, they make these things that kind of plug in. They're called shields. So that's kind of the terminology of kind of some of these boards, whether the Intel boards, the Arduino boards. You have basically something like this, and you have the ability to plug shields into it. Makes it easy, kind of plug and play. The pins line up. You're not soldering anymore. There's another neat shield configuration by a company called Grove, and they're very popular with a company called Seed. And these are generic Arduino shields, and they just clip in. Again, no soldering. It's a great. It's a kind of a revolution with these IoT kits. And with that, you were asking, do I just plug it in? What wires do I need to do? But what it does is it kind of takes the soldering work out of the fun. So just like that, you plug it in, and you've got your connector. You don't have to worry about polarity. The pins go either way. And these shields, or this particular company, Grove or Seed, produce a host of connectors. So I'll show you how to find out a little bit more of those in a second, but just to walk through the rest of the code here. So commented out here are all the super secure passwords to connect to the various web servers. So I set up a bunch of accounts to run 15 different web servers, and I just put the channel keys in here. So how that works is there's an API key for when you connect to this ThingSpeak service. We saw before, this is the SSID of my Wi-Fi hotspot. Here's my password. And then this is the web server or the application server for ThingSpeak. And let me bring that up here. It's a great service. It's free. They just got acquired by MATLAB over the summer, but they still offer a free platform. You can have, I think, an unlimited number of channels, and you can post sensors up there with a frequency no more than 15 seconds per channel. So I don't know if any of you got to the point where you were actually publishing to this yet. I published a couple this morning. for that to come up. So here you're defining the pins, the particular pin for that humidity sensor. In an Arduino program, much like a C program, you have a kind of a setup statement where you're defining some of the init statements. You're setting what the serial line speed is. You're saying, let me start a Wi-Fi session with my SSID and password. It's connecting. We give it a couple seconds to connect. And it's in a loop while it's connecting. That's why you see the ... I've got a loop here where it's just reading the temperature and the humidity. In the event that the temperature and humidity don't come back as a number, so it's not a number, it's going to let you know that it's failed. One of the biggest paradigms I've kind of come across with IoT versus traditional programming is you really need to code for failure. Hardware fails a lot. I know I said they're very stable, but stable in failure, it's overall failure versus sensor frequency failure. There's going to be a lot of bad sampling, and there's a lot of strategies to kind of counteract that. Simply, what it does next is it's just concatenating a string. This is how you post the API to ThingSpeak. It's embedding the API key in the header here, and then the post string is just the field 1, field 2. So billions and billions and billions of data points. Or not. Okay. So I went in earlier and I created 15 SATURN channels. I defined 2 channels, a temperature and humidity channel, and you can see that it's just posting that data up. That simple program is feeding that up every 20 seconds, and this data is, you can do all kinds of visualization. If you want to have your thing publish where it is in the world, you can display on Latin long. Yeah, that's where I was this morning. Yeah, so I didn't want to do. Well, there's security. I didn't want to, let anyone know where we were at. But all these visualizations, again, it's all free. There's a bit of an analysis, but there's also a robust API in here that you can do. This thing will push tweets. I don't know if you're familiar with if this, then that. There's an if this, then that trigger inside of here, so you can have your weather station if it's over 85 degrees in your hot tub to, take the top off, or anything like that. So that's. And I don't know, did anyone get to the point where they're publishing data to this yet? Problems? Publishing to here? Oh, sure. Okay. Well, we'll take a look at it because it'd be neat to see some data come out here. So let me go in here and clear out my data here. So you can also have a public and private view. You may have public channels that you'd want to share data with, but you can also have private channels as well. Okay, somebody is definitely pushing data out to it. We just got a 23 degrees Celsius and a 47% humidity. So everybody just start breathing heavy, and we'll see which one of you it is. Okay, anybody think they have it running? It's you guys? Look at you. Well, I do have some giveaways. Like I said, I end up with a lot more hardware than imaginable. You guys want a couple goodies for your hard work? You got one too. Here. These are kind of neat boards. These have GPSs in them with batteries. Okay, so you guys are having trouble compiling? Transfer. Oh, to the board? Yeah, you guys probably don't have the luxury of this down under the ocean. Push the reset button. Sometimes you just want to hold the button and then
There's a reset button?
it's a little teeny tiny reset button on here. And sometimes it just the sensor it hangs up. So, so go up to there, yeah.
Windows technique works, I think.
What's that?
Windows technique works, I
Yeah,
think.
that's right. Control.
Reset,
That's right.
reset,
Control Alt Delete. The 3-finger salute.
Or no one is from Windows in Microsoft.
Okay. And you guys pushed this already, right? So this isn't a new problem, or I mean, it's a new problem, not a. Did you change the upload speed? Is it 96 or?
96, yeah.
It's awful, awful, awful. This one or this one?
That one.
That one. Options change, rebuilding all. Let's see if that works. Yeah. Woohoo! So you can look at the temperature or the humidity here. Okay, oh, you're there. Okay. The next one in the lab here, you want to. So you want weather station ThingSpeak. Yep. That publishes up to here. Okay. What's that? The relay works, yeah. So what's cool about that is, if you think about that, for the relay, I think is a little more expensive because I think it's about $5. You could have a web service endpoint, turning on and off your garage door opener from your phone, just with the on-off switch of your website. No, well, you complete the circuit. So you can center pole is. Would be your positive. You'd wire your negative into the device, and then this closes the circuit. So this is a solid state relay. You can run 220 through that. 220? You can run 220 and 12 amps, or no, sorry, 220 at 10 amps, or 110 at 12 amps. So I've run fans, garage door openers. You really can run. That's right. In my greenhouse. In my greenhouse, I do. No.
So I can shut off my kid's Wi-Fi?
You could shut off your kid's Wi-Fi, yeah. You guys good, or you got up to the weather one? Okay. I'm glad we're making a little progress. Yeah. Okay. You're still stuck. Okay, error compiling. I wonder if this is the bad cable. Okay. I wonder if that cable is bad. Hardware problems. Yeah.
Is there a way where you can actually look at the error codes and stuff on their website?
Yes, I mean, definitely. Most of these things are Googleable. Oh, what's that? It's
getting the same
still completely dead.
Do you have this?
I don't know if that's get the relay. Relay. Let me see. I might have left one floating around on the table. There's that one. Oh, there's this one. Has anybody got an extra board they're not using? Nope, 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 nope. Not yet, okay.
It's uploaded.
Oh, here's one. Here's an unused one. So try that one, and you can try the sensor on top, yeah. And it just there are some numbers on the pin, just make sure they line up. Yeah, just pull it off like this.
Yeah, but I need the proto board as well.
You don't, the proto board's just so you don't poke yourself.
Okay.
Okay,
Oh, yeah, of course, because you're not putting...
TX, right, okay, yep, just like that.
Put it in the right way. Yeah.
There you go.
Let's try that.
So, that's a Dimego, yep. Came out of my 3D printer. Okay. Did you guys map yours to the second one? What's that? Oh, Weather Station 4? You're 4 as well? 12. Oops. Yeah, then you would really appreciate security. Okay, so we got 4. Let's see how 4 is doing. Okay, let's channel 12. Can you bring up the console, see what's going on? Okay. There's 12. Good job, 12? 12?
There's one too. That's also MRD.
Oh,
It's
did I
just based on
copy
the
it?
API key, right?
Yeah.
So no, they're a little bit different.
Just a standard shield. Oops.
I looked into the Grove ecosystem sometime last year. I wanted to see if I could build. I can best describe it as a shit detector.
Do you need like smell, like methane?
Yeah, I have lots of dogs.
Yeah. So there's
And I couldn't find one that was sensitive enough.
Oh yeah, that.
And I asked a bunch of people and online and whatnot, and they're like, there doesn't really exist a methane sensor that is strong enough to be able to detect dog poop.
Yeah.
Which is really what I wanted it for. And there's ones that are strong enough to detect cow poop.
But yeah, dog poop I think doesn't only smells when it's wet.
Pretty much. And the smell goes away quickly. I had a dog that pooped her crate a lot. I really wanted to science it.
Yeah, I wonder what other options. Did you guys figure it out? Oh. You on channel 1? Did it work any better? No? Progress is good. Who's sitting on it? Who's sitting on their board? That's good. How are we doing on time? We got 15 minutes? Okay. Oh, no. Oh, sorry, I didn't say the light. Let's see. Okay, so did you put a different key in or? No. Okay, then you're publishing on channel 1. Yeah. So you can go and grab a different channel key if you want and put it in. Did you guys get any further?
Well, yeah.
Except you're.
It's uploading.
Okay.
So,
And it's okay. It says it's done. So if you open the serial monitor now.
Yeah, we have to close down all the Arduino editors.
Oh, you did?
Yeah, and then we open it back up.
And it worked?
And it worked.
Okay, so connecting to Saturn Weather Station 10. Wow, look at you guys with the heavy-duty commenting. Let's go see if any data is coming up on 10. Okay, nothing on 10 yet. Still getting dots? Sorry, giving you guys a workout. I didn't realize you were following me around. I would have stayed still. No, yeah, that's the right. You want to try resetting and see if we can see it from the beginning. Make sure the Wi-Fi is connecting. Just push the button. Just for a split second. Did you? Okay, so we got.
Should be something I did with
So you two are together? No, I mean not together. Okay. Yep, hedgehog is the right one, but it shouldn't be here. That one should that be the hedgehog as well? So, oh, you changed it?
I changed it, yeah.
Oh, okay.
Because it said in the comments.
Oh no. Change that to E, capital E, T, capital T. Was it E2 hedgehog? No, sorry. Let me tell you. No.
Capital E?
No.
See, it's not easy.
Yeah, it's not.
Okay, so we have to just flash that again, I guess.
Yep. So I'm going to give away a couple things, but if you guys want to keep one of these to play around with, to take home. I mean, if you can sneak it on the plane, no one will think it's a bomb.
The source code that we are using, is that something we can have? Or?
Yes. Oh, yes. What I'll do is I will publish it someplace for you to have, just to play. I mean, they're easy examples, but they're good to have. Sure. Okay, two last things, housekeeping, because I think we're almost out of time. First of all, thank you so much for your patience. Hardware, sometimes bumpy. I don't know if you guys have cards or if you just want to take your card, your little name tag, and put it in the bag. I have an Intel Edison to give away, which is a $100 board. If you want, I don't want to pressure you. Just put a card or your name tag or something in the bag. There you go. Here, I'm gonna. Okay. You can just put your name tag. You can have it back. I'm not gonna keep your name tag. I'm not gonna sneak into your room. I'm not gonna do anything like that. Uh-oh. That's right. As long as you have one badge, that's fine. Okay, weather station 10. That you guys? Excellent. Don't lick it. Yeah. So those boards, the little boards you're playing with, they're lest you think I'm crazy. They're the chipset itself, the ESP8266, is a $2 board. Like I said, it's on a power controller. You could buy the $2 chip yourself and put the wires in and solder it, or spend the extra $2 and get the Wemos chip for $4. I mean, it sounds crazy, but you can get them on eBay. There's a website called Banggood, which is not what it sounds like. No, wait, stop. 2 O's. 2 O's. I think they're no. The upside downside is a lot of these. This particular Wemos is a Chinese chip. I'm on like amazingly slow website, I guess, or maybe. But enough about that. Everybody put their card in? Yep. Everybody in the main pocket, they're not in the... Okay.
Oh, that's me, man.
Is it?
Sorry, suckers.
Man. Yeah.
I just put it right up there, like that.
There you go. Make sure you grab your card. So this is a Intel Edison. This is a nice board. It's a Linux on a chip. And what's nice is it comes with an Arduino shield, so you can pick up any one of these Grove kits. Here you go. So, thanks. Again, thank you for bearing with me. It's, what my hope is, or hope was, just get a little exposure of what, some of the hardware looks like, what the chips can do. And again, please feel free to come take a look at some of the sensors if you have any questions on some of them. I think I literally have a sensor for everything, except for bad flash drives. I am having office hours tomorrow, unless you have some complaints, and then it's on Friday. So then, please, feel free. I didn't get to the BB-8 demo, which I will have up and running for the demo on tomorrow. And what that is it's an MQTT push. So basically, from the web server, you push MQTT messages. What it's meant to demonstrate is how sometimes some protocols are not right. Everybody's pushing to a queue for a robot. You're probably not going to send it where you want. But it'll be an interesting demo if you want to come check it out on Thursday, or if you have any particular questions on sensors or want to talk more IoT stuff, I'm happy to try. Thanks. Thank you.